was really hoping for a few more here at the start. That way we could start off with a review game. But I'll go ahead and kind of give the intro and kind of give you a heads up of what to expect this week. So obviously we've got class today and Thursday. Today is kind of a day to make sure we're all on the same page, kind of review over systems of equations by graphing. So, you know, if we started off this this unit, so to speak, right, we talked about how to check if a solution, you know, if we're given a coordinate pair like 2, 3 or -1, 2, we're given a coordinate pair, could we take that point and test it within two equations, a system of equations, and see if it works for both of them, right? So that's what we started with, right? And I'm gonna share this screen here. There we go. Not that. There we go. This is just the notes that we took kind of throughout the past week or so. So, you know, we started off and we said a system of equations is two or more equations, right, that have the same variables. And so the first thing we said is, you know, what is a system of equations? Like, these are not systems of equations because these are only one equation. And this one has two equations, but this one's x, y, and this one's a, b, so they don't have any connection. Okay, so, you know, that's what we started with. We then went to checking solutions, right? So the solution is the coordinate point, or the point that makes all of the equations in the system true. So that's when we started saying, okay, what if we take this coordinate point, if we're given one, and plug it in and see if we get true statements. So that's what we did here, right? We plug in -1 for all our x's and a 2 for all our y's. Let me write that there, x, y. And we plug in our x's and our y's and we see what happens. So like this one, we said 3 times -1 is -3, plus 5 is then 2. Okay, and then the 2 over here, there's nothing being done to it, so it's just 2 equals 2. Check mark, we got it, right? It's a true statement. And then over here, plug in the same things. 1 minus -1, we said that's the same as 1 plus +1, right? So that's 1 plus 1 is 2. 2 again is nothing's been done to it, so now it's 2 equals 2 again. True statements all around, right? So this is in fact the solution. Yes, this is the solution to this system of equations. Okay, so then we tried it with different points. You know, is 2, 5 the solution to this? And we plugged it in and solved. Is 1, -2 the solution to this one? And we plugged it in and solved. So that's where we kind of started off on, right? And then from there we said, okay, you know, if we have two lines that are graphed, can we figure out where the solution is? So it's really the same thing, but instead of two equations and plugging in a coordinate point or coordinate pair, we find the coordinate pair based off of the image, right? So if we looked at these two graphed lines, we said, okay, this point of intersection is at 1, 2 over, comma, 1, 2, 3 up. So 2, 3 is the point of intersection, right? That's a solution. And then, yeah, so and then that next day they were all problems saying, okay, if they're already graphed, where would we put the solution? What would the solution be? And it's always just going to be where they intersect, -1, 3 on this one, right? And so that was where we went next, right? We said also if they don't intersect then, okay, that there's no solution. Okay, and we said if they're the same line, so like these two equations they look different, but they're the same equation. If it's one line right on top of the other, then it is infinitely many solutions, because we're basically asking, where do they intersect, right? Excuse me, pardon me. This one says, where they intersect. And we said right there, right at 2, 2. This one says, where do we intersect? And we say, oh, it doesn't intersect. So it's no solution. So if they're the same line, we say, where does it intersect? Well, it intersects every single spot, right? If they're right on top of each other, it's like boom, 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 boom. All in a row, it's all touching. So infinitely many solutions because it touches infinitely many times to the other line. Okay, and then the last thing that we kind of went over and practiced was, okay, now what if we graph the lines? So one was checking the solution with equations. Then it was, can we find the solution based off of a graph? And then now we're the ones graphing both lines and then checking where do they intersect. So looking at the screen here, right, we would graph each of these lines. So, we'd graph this line, we'd graph that line, and then we'd see where do they intersect. I think we did some of those on our slideshow. But here's an example here, right, where we said, okay, y equals 2x minus 4. We'd start at -4 because that's our y-intercept. And then our slope is 2, or 2 over 1, so we'd say rise 2 over 1, rise 2 over 1, rise 2 over 1. That would be like for this guy. And then for the other one, we said, okay, y works the same way. Y equals -3x plus 6. So we start at plus 6, because that's our y-intercept. And then we go down 3 and over 1. Down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. And again, the way we know how to move on our slope is if it's not already a fraction, we have to make it a fraction, so to speak, right? So this one, we would say it's -3 over 1. Oops. -3 over 1, and if it's, and if it's a negative, it's going to go in the negative direction, right? So if it's rise over run, and we have a -3, we know, okay, that's either going to be up or down, and it's a -3. So that's a negative direction is going to be downward rather than up. So that's why we did the down 1, 2, 3. You can see here. And then a +1. So we say, okay, the run is a +1. So positive would be to the right side of the number line, and negative would be to the left side. So we would say down 3 and right 1. And then down 3 again, right 1. We would just repeat. All right, so we started graphing the lines of the equations and finding the points of intersection as a solution. All right, and so, and then once you find your point, if it's done correctly, you know your answer, you know your solution. And if you wanted to check your solution, you would just do what we did at the very beginning of this unit, where you plug in that point. In this case, it's what, 1, 2, 0. You would just take your answer, 2, 0, and plug that into your equations and see if you get 2 true statements. Okay, if you do, then you know for a fact, without a shadow of a doubt, that you got it correct. So, I know that was kind of like a speedy run through, kind of a speedy review. First of all, any comments or questions about how we did that? Because I don't want you to have any questions moving forward other than just practicing and understanding. Do you have any questions about what we've done so far, or one of the different skills we've learned, whether checking a solution, looking at a graph and finding the intersection, graphing 2 lines and finding the intersection, anything in there? Okay. If not, if I don't hear from you guys, I'm assuming that you don't. But if you do, again, one of the nice things about Zoom is that, I mean, I can work with you. We can answer any questions, especially because we only have I only have one 8th grade class, so obviously our classes have been really small. So we can use this time to help answer any questions that you guys have to help you. Okay, so. All right, if you think of any, let me know. We can always pause and go from there. So today we're going to do a couple different review games to see kind of where we're at and how we're doing. And this will help you know how you are doing as well with the material. So I'm going to go ahead and try this as individuals. Ideally, team would be best case scenario, but for what we have here, we're going to do as individuals. Okay, so head over to Quizlet.live, and you can go ahead and use this code here. And we're going to get joined in. All right, I posted the web address and the password so you guys can join in. I'm going to stop sharing here because I think I'm going to play as well, just for fun. Six two. Good. Got Emma in. Edna, I'm sure, is right on her tail. There she is. Awesome. All right, let's go ahead and get started, and then we'll see how it goes. Okay. All right, let's go ahead and get started. Do your best. I'm going to share the score here. You can click on the picture to make it zoom in, guys. Oh my gosh. Wow. That was super quick. Okay, let's play again. Do a little rematch here. Alright, ready? Go. 2 minutes. Okay, I'll watch my phone. Take about 2 minutes and actually look at those and see what questions you missed or what you got right away. Okay. Just check over those real quick. Excellent job, man. So that was our first checked over those. Good job. Alright, we're going to go ahead and do another one. Okay, this next one is going to be a little bit trickier. This one's going to be not just where's the solution or what the solution is, but also a little bit of other facts that we're going over when we're talking about. Put the second one. Here. There were a few, like I said, that were a little bit confusing. Anything in the parentheses really didn't make too much sense. So don't let what's in parentheses really get to you as far as like this answer is a crap. I'd like for us to do is go ahead. I'm going to give you guys again a couple minutes to look over which questions you missed. Okay, you guys got a lot of corrects. You guys did really well. Just look over and see which ones you did miss and why you missed them. And then we're going to do one example problem together. And I think that'll clarify a lot of questions. We'll play this one more time and then we'll be done. Okay? So I want to see how well you guys can do. So take 2 minutes, 3 minutes, look over which questions you missed, why you missed specific areas, and then we'll go over a example problem together, and then try it one more time together. Okay? Alright. All right. So hopefully you were able to go over those, and I was able to help you kind of see which questions you missed. Right now, I'm going to go ahead and share my screen with you guys. And as promised, we're going to look at just one example problem. Because again, all of our skills that we've done so far have been just building up to solving a system of equations by graphing. That's all it is. So here on my screen, you can see this. I have an example problem. Right? We've got a system of equations, y equals 2x minus 2. y equals negative 2x plus 6. Okay. Testing. Is that a little bit better? Can you guys hear my voice? Okay. All right. Yeah, it looks like the mic is not as loud as it should be. So I'll just talk a little bit louder. All right, so back to our problem real quick. So if this is a system of equations, here's a couple tips that'll help you guys, okay? Again, I'm going to have you guys answer in the chat. If I have y equals 5x, say 5x plus 2. And then this one says y equals 10 over 2 x plus 2. How many solutions are there going to be to this system of equations? What do you guys think? How many solutions are there going to be to this system of equations over here on the right? In the chat, I want you guys to go ahead and tell me what you think. Oh, yeah. If you can, you can go ahead and close and mute that music, okay? Either close the tab or put the little microphone at the top of the tab to mute it. Yes, guys, you should be able to exit out of that tab, that Quizlet. Okay, I've already closed mine, so it shouldn't be coming from my end. If it is, I will do that, just in case. Is that better? Okay. All right, guys, so if we have this system of equations on the right, how many solutions would we have? Would we have no solutions, one solution, or infinitely many solutions? If it looked like this on the right, what do you guys think? Go ahead and answer in the chat real quick, Edna and Emmett. What do you think? Is it no solution, one solution, or infinitely many solutions? Or I don't know. You can put that. Okay, got no solutions, no solution. Okay, so let's check it out. So here's a couple of tips that'll help. This one says y equals 5x plus 2, y equals 10 over 2x plus 2. Okay, 10 over 2, we could simplify that, right? 10 divided by 2 would be 5. Okay, so this is actually, oops, this is actually a 5. So now it says y equals 5x plus 2, y equals 5x plus 2. Okay, so they're the same equation. Okay, it didn't necessarily look like it to begin with, did it? But they're the same equation. So if, is that right? Yeah. Okay, so if they are both graphed and they look something like this, okay, because it's the same line, right? So you'd graph one and then you'd graph the other and they'd be right on top of each other. So how many solutions is that? How many times are those lines intersecting? Are they not intersecting? Are they intersecting once, or are they intersecting at every single point? Okay, good. Infinitely many spots is where they're touching, right? Because they're the same line. So here's the tip. If it's got the same slope and it's got the same y-intercept, it's the same line, okay? Which means that it's going to be infinitely many solutions. Okay, so I'm drawing my infinite symbol here. It's going to be infinitely many solutions if it's the same equation, and this one was. Same slope, same y-intercept. Okay? All right. Tip number 2. If you've got two equations, let's keep the first one. No, let's mix it up. Let's say y equals negative 2x minus 7. And this one says y equals negative 2x plus 2. Okay? So if this is our system of equations, how many solutions do you think this thing's going to have? You think it's going to be one solution? Is it going to be no solutions, or is it going to be infinitely many solutions? Go ahead and say in the chat. What do you think? Okay, I've got one solution, one solution. Okay, all right. Thanks for your responses. This one is actually going to be no solutions. Okay, and that's tip number 2. So one was if they're the same equation right on top of each other, it's infinitely many. Okay, now this one, they both have the same slope, don't they? Okay, so that's the clue here. Okay, if they had the same slope and the same y-intercept, it would be infinitely many solutions, right? But these don't have the same y-intercept, so they start at different spots. So let me actually graph these for a sec. Negative 7 on our y-intercept would be right here. Okay, and then the slope is negative 2 or negative 2 over 1. So rise negative 2, run 1. Rise negative 2, run 1. I can go backwards. Up to left 1, up to left 1, up to left 1. Okay, so this is our, about here is where our line is. And then this one starts at positive 2. So I start at positive 2, place a point, and then I do my slope, which is negative 2 over 1. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Okay, you get the gist. So here's my second line. Okay, and if I drew this even straighter, you would see that, hey, those are parallel lines, right? Those are parallel lines, which mean that they never intersect. So anytime they start at different spots, like these guys do, right? They can start at different spots on your y-intercept. But if they have the same slope, the same tilt, the same hill, right? They're never gonna intersect. They're never gonna hit each other. So the only way they'd hit each other is if they have different slopes. I don't know if you can see my arms. As if they'd have different slopes like this or like that, right? But if they have the same slope, then they're never going to touch. Okay, they're just going to keep going forever in each direction and not touch. All right, so if it's the same slope and y-intercept, they're the same equation, it's infinite. If it's same slope, you know that it's the same tilt, doesn't matter where they start, they're never going to touch each other. Okay, and then the last one is if they have different slopes, different y-intercepts. Okay, so let me write that here, and I would either write it down on a piece of paper yourself or commit it to memory. So it's going to be infinitely many solutions when they have what, guys? What do I need to have to make it infinitely many solutions? What'd you guys put? So for them to be infinitely many solutions, does it need a same slope? Does it need a same slope and a y-intercept that are the same? Or what does it need for infinitely many? Real quick, what do you guys think? Ooh. All right. Well, okay. If it's infinitely many solutions, guys, right? Infinitely many solutions, it's going to be the same y-intercept. Same. And again, sorry for the bad handwriting. Same y-intercept. And same slope. Okay. If they're parallel, same slope. Same slope. Different y-intercept. Okay, and then this last one is going to be, if it's got one solution, that means that they have different slope. And different y-intercept. Okay, so this right here, guys, this is what's key. Oops. Okay, so this is an easy way to just look at something, look at a system of equations and know if it's one solution, no solutions, or infinitely many solutions. So this one, let's take what we learned there and apply it here. Both of you guys, I want you guys to look at this equation here. Just by looking at this and not even graphing, I want you guys to tell me how many solutions is this thing gonna have? Is it gonna have one solution, no solutions, or infinitely many solutions? Based off of the information on the right-hand side. Go ahead and type in the chat what you guys think. Come on, guys, what do you think? How many solutions is that system of equations circled on the left? How many solutions is that going to have? One solution, no solution, or infinitely many solutions? No penalty, just go ahead and put what you think. Okay. All right, I don't know if you guys are there. Hopefully you are. But just by looking at this guy, right, let's check this out. Do they have the same slope? No, not quite, right? This one's 2, this one's -2. So they have a different slope. So that means it can't be parallel because they've got a different slope. And it can't be infinitely many solutions because it's got a different slope. So it has to be one solution. So we know this thing's going to have one solution. It's not going to be one solution. It's not going to be parallel lines. It's not going to be the same line. It's going to be two different lines hitting each other. Okay, and then I could graph. I could say start at -2 and slope of 2. So rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Okay, and then I could graph that line. Okay, and then the same with this guy. I could say, okay, starts at +6. Slope is -2/1. So I could go down 2, right 1, down 2, right 1, down 2, right 1. Okay, and then I can draw my line. Okay, and so they're going to intersect right here at this point. Okay, which is at 2, 2. All right, so that's an easy way to check. Easy way to check if it's got one solution, no solutions, or infinitely many solutions, just by looking at it, and then that's how you graph and check your solution. Okay, so one last time, guys, I want us to just check. Good, yes, they meet at 2, 2. That is correct. But yeah, so anyway, just by looking at this equation, we can know how many solutions it's going to have by using this info on the right, okay? So if it's got the same y-intercept, same slope, infinitely many solutions. If it's got same slope, but different y-intercepts, then it's going to be parallel lines, right? And if it's got a different slope, different y-intercept, then it's going to be something like this, right? Two lines hitting. All right, let's try our game one more time, and then we'll be done for today, okay? So I'm going to go ahead and share the code, and you guys can see if you can beat me this time now that you guys saw that and are a little bit more warmed up. Okay. Here is the code. 206567. All right, guys, in the chat, Quizlet.live, 206567. That's where I want you guys to go so we can finish up. Excellent. All right. Sorry. Share screen. You guys got this. Listen carefully. done. Alrighty, guys. So that is our game. All of you guys did so awesome. Let me close this. All right. Thank you guys so much. You guys did fantastic. Again, feel free to ask me any questions. Shoot me an email. You can say, hey, Mr. E, can we Zoom chat real quick and you work out a problem on paper or something for me? Or even if you just have a question you can ask on text, you can do that too. Okay. But yeah, thank you guys so much. You guys did great. The only assignment for today / tomorrow is to make sure that you're caught up on your assignments. Okay, so just I will post in Google Classroom once we're finished with this on the stream, and it'll be that Elander math info sheet Google Doc where it shows what assignments we've had, and just make sure that you've said, okay, I did that IXL to 80, I did this quizzes, I did that, and just make sure that you're all caught up on your assignments. Okay. All right. Have a great day, guys.